Reuters reported this morning that SpaceX has agreed to buy Anysphere. Anysphere makes Cursor. The reported price is $60 billion in stock. TechCrunch has the same core report and puts it days after SpaceX's blockbuster IPO, while TechMeme is treating it as the lead industry item. So start with the plain fact. One of the coding tools a lot of developers already have open all day may end up owned by SpaceX. My first question is deliberately mundane. Cursor can sit in the commit loop, the code-based search loop, and the pair programming loop. So what changes when the owner is no longer a developer tool company raising venture money? What changes when it's a public market adjacent infrastructure and aerospace company with its own compute appetite and internal software needs? I don't have a source saying the product changes tomorrow. I wouldn't assume that, but ownership changes the incentives around a tool that already sits very close to private code.
And for a developer, that closeness makes it different from a normal acquisition headline. A chat app gets bought, and you worry about features. A coding assistant gets bought, and you also worry about repository access and telemetry. You worry about enterprise contract terms. You worry about model routing. You worry that the thing helping you edit code now sits inside a company with very specific engineering priorities. The deal can be ordinary in the legal sense and still meaningful in the workflow sense. A stock transaction, board approval, and deal close language are normal, but the tool is already in the place where mistakes become patches. That makes the next facts worth separating. What Reuters says has happened, what TechCrunch says about timing, and what nobody has announced about product behavior.
Right. The simplest version is the reported agreement. SpaceX buys Anysphere for $60 billion in stock. Cursor becomes part of the SpaceX orbit if the deal closes. Everything after that is inference. The tempting read is to make this a Musk grand theory. Code assistant plus rockets, compute, and whatever social network and AI assets are nearby. I want to keep it closer to the builder's desk. Cursor is valuable because it became a daily surface. It knows the rhythms of a repository. It has users who may have forgiven weirdness because the product helped them ship. Under new ownership, the product has to keep earning that trust with plain things. Pricing can't surprise teams. Enterprise controls have to make sense to procurement. Model choices can't become a mystery box.
The mystery box point is where I'd push. Cursor already abstracts model choice for many users. You ask for the change. It opens files, edits, and explains. If ownership adds another layer of company-driven routing, the user may not know why behavior changed. Maybe the model changed. Maybe the retrieval layer did. Maybe cost controls or a new internal priority changed the answer. That doesn't mean something bad happens. It means the post-deal product promise has to be legible. Teams need to know where data goes. They need retention rules and enterprise isolation terms. They also need to know whether service reliability gets better because SpaceX can throw infrastructure at it. It could get more complicated because the owner has its own demand for the same resources.
There is a funny inversion here. We have spent the last few years watching model labs reach into developer tools because software is the obvious place to sell intelligence. This deal, if it closes, points the other way. A company known for physical infrastructure and capital intensity reaches into the developer loop. Again, that isn't destiny. The source material today gives us the reported transaction, not the operating plan. But if you run an engineering org using Cursor, the short list of follow-up questions is already visible. Do contract terms transfer cleanly? Does support stay focused on outside developers? Are model providers still chosen because they work best for the task? And if pricing changes, is it explained before the invoice hits?
And retention. A lot of developer tool acquisitions look great on paper until the people who loved the tool start looking for the nearest exit because they don't trust the new owner's priorities. Cursor's asset isn't only the code editor integration, it is habit. Developers will put up with a lot for a tool that saves them time, but they get jumpy when a tool near source code starts to feel politically, commercially, or operationally unpredictable. The generous read is that SpaceX wants the best coding assistant company in-house and can keep investing. The skeptical read is that a broadly used developer surface becomes another company asset in a much larger machine. The next evidence should come from Anysphere and SpaceX, product commitments, enterprise data terms, and who stays in charge of the tool.
TechMeme's OpenAI cluster points to Financial Times reporting that OpenAI spent $34 billion in 2025, with $19 billion on research and development and nearly $6 billion on sales and marketing. The Reddit links around the story are mostly reaction and retelling, so I would keep the proof path on the reported audited figures surfaced through TechMeme and FT. Those numbers give a hard edge to a story that otherwise gets described through vibes. The story includes model access, data centers, vendor dependency, and pricing. $34 billion isn't a feeling, it is payroll and compute, it is research bets and customer acquisition. It is also the cost of staying close enough to the frontier that customers believe the next subscription bill is buying more than yesterday's model with a new name.
The sales and marketing line matters too, because it says the spending isn't only training runs and chips. OpenAI is paying to create demand while it pays to satisfy that demand. That is a hard position to manage. If the revenue curve is fast, but the serving and research curve is faster, the company has to keep finding money. It can also raise prices, cut serving cost, or move customers toward plans that make the unit economics less painful. Developers feel finance as product behavior. Rate limits can change. Tiers can move. Enterprise minimums, model deprecations, usage caps, and routing defaults can all be accounting decisions expressed as interface decisions.
That is why I don't want to turn this into a moral lecture about burn. Frontier AI is expensive. Everyone serious knows that. The interesting detail is the mix. Research and development at $19 billion says OpenAI is still buying its way through capability and systems work. Nearly $6 billion in sales and marketing says customer capture is expensive too. The result is a company that has to be both a lab and a distribution machine. When it asks enterprises to standardize on its models, it is selling answers and also asking for belief in the company behind them. Customers have to believe OpenAI can fund the next model. They also have to believe it can serve the current one, keep policy stable enough for procurement, and preserve enough margin that the product doesn't get constantly rewritten around cost pressure.
And that folds back into the cursor story in a useful way. Developer tools are attractive because they sit at the point where usage can become habitual. But habitual usage can be expensive when every accepted diff, every codebase search, and every long context session has model cost underneath it. So if a coding assistant is worth $60 billion and a frontier lab is spending $34 billion in a year, the practical question for a builder isn't who has the best demo. It is who can run the service at the quality level you now expect without turning the pricing page into a monthly surprise.
The GitHub capacity report makes that point less abstract. TechMeme has Business Insider reporting that Microsoft is adding AWS capacity to GitHub after AI-driven growth strained infrastructure and reliability. We don't need a long detour there. It is just a very concrete sign that AI demand is hitting core developer infrastructure, not as a keynote slide, but as capacity planning. GitHub is already the place where a lot of engineering work coordinates. If Copilot-style usage and agentic workloads put enough pressure on the system that Microsoft reaches for additional AWS capacity, then the compute story isn't limited to labs training models. It is now in the reliability budget of the tools developers use to push code.
That one is operator catnip. You can talk about intelligence all day, but somebody still has to provision capacity. Somebody has to watch latency and absorb bursty usage. Somebody has to explain why the repo UI slowed down when the assistant feature got popular. And it also gives us a better way to read the OpenAI spending line. Some of the money is making models smarter. Some of it is making model use survivable inside products where outages are immediately visible. If AI becomes part of the developer's normal path through GitHub, VS Code, Cursor, and CI, reliability stops being a back-office concern and becomes the product.
The Anthropic Fable and Mythos story got new reporting today, but I want to treat it as an update, not as a replay of the last 3 episodes. The Verge has a fresh inside account of the conflict with the Trump administration over model access and export controls. Axios frames the dominance and China risk argument. Indian Express says Anthropic and the U.S. government are in talks. Forbes recaps the order. The new technical wrinkle comes from the register item that Hacker News picked up. According to that report, the behavior that alarmed federal officials may have involved a simple "fix this code" prompt rather than an elaborate jailbreak. That detail needs attribution because it is disputed territory.
But it matters because the policy response looks very different if the trigger was an exotic exploit versus a normal developer interaction that produced dangerous capability.
That distinction is enormous for builders. If a model crosses a policy line only after someone chains together a contrived attack, the response can be red team scope, classifier work, and tighter evaluation. If a normal code repair request exposes the behavior officials fear, then the boundary runs straight through ordinary developer use. And the awkward part is that "fix this code" isn't a suspicious phrase. It is the whole product category. A developer asks for repair, the model reasons about the bug, and sometimes that reasoning is dual use. You can't wall off all dangerous knowledge without affecting legitimate security, systems, and reliability work.
Exactly. And that is where the export control story becomes hard to administer. The government can say the model is too capable for broad release. Anthropic can say access restrictions harm customers, researchers, or security work. Both claims deserve to be taken seriously. The missing artifact is the technical basis that lets outsiders understand the line. The Verge reporting may explain the fight. Axios can explain the policy pressure. The Register can narrow the technical dispute. But without a public advisory, model card addendum, or reproducible evaluation description, developers are left with second-hand accounts of a boundary that can remove a model from their stack.
And because Braid has already spent several days on this, the fresh lesson is smaller and more practical. Access policy is now part of system design. A team that depends on a frontier model for code review, exploit analysis, or high-end reasoning has to model government intervention as one of the ways the dependency can disappear. That sounds dramatic until it becomes a runbook line. Which features degrade, which customers get notified, which model takes over, which evaluations decide that the fallback is good enough for the task. If the government can remove a model from circulation, the engineering team needs an answer that is more concrete than "we'll switch providers."
There is also a fairness problem for the labs. If the standard is fuzzy, every release becomes a negotiation under uncertainty. Anthropic isn't just deciding whether a model is safe by its own internal tests. It is trying to predict how the government will read the same evidence, how competitors will respond, and how customers will price the chance of sudden access loss. My read, with that caveat attached, is that the next useful document would be plain in format and valuable in substance. It should describe the tests or incidents that justified the restriction. It should say who was affected. It should also give customers a process for appeal or restoration. That wouldn't settle the politics. It would at least give builders something to implement against.
I would add one more requirement. Say what normal developer tasks are supposed to do. If the disputed prompt is in the family of code repair, then the policy has to name the actual boundary. Does the control attach to the task or the target code? Does it depend on the model's depth of reasoning, the user's jurisdiction, or whether monitoring is present? Those are different controls. You don't solve them with one access switch. Scoped permissions are one answer, logs and model routing are another. In some cases, the product needs a refusal that tells the user which boundary they hit. The current reporting tells us a fight is happening. It doesn't yet tell a developer how to build a reliable product on top of the affected models.
The RxIV pool today is huge, so I am not going to pretend every paper deserves equal space. The useful cluster is narrower. It gives us open agent models, coding traces, concurrency control, and memory security. Start with Ling 2.6 and Ring 2.6. The paper says Ling is optimized for instant response generation and high capability per output token, while Ring is tuned for deeper reasoning and more advanced agentic workflows. They aren't training from scratch. They describe an upgrade from Ling 2.0 using architectural migration pre-training, large-scale post-training, and agent training environments. They also say the 2.6 checkpoints are open, so the practical headline is an attempt to package low-latency response and deeper agent reasoning as separate but related open artifacts.
That split maps to how people use coding agents. Sometimes you need the assistant to answer fast and stay out of your way. Sometimes you need it to sit with a failing test suite, inspect the repo, plan across files, and make a multi-step repair. Treating those as one model behavior can be wasteful. The paper's K-pop reinforcement learning framework is also pointed at environment-grounded data across coding, search, tool use, and workflow execution. I would keep the claim provisional because this is a paper, not weeks of independent usage. but the direction is concrete. Open agent work is moving from chat quality toward how the model behaves inside an environment with tools and feedback.
NVIDIA's Nemotron 3 Ultra paper is more spec-heavy, and the specs are worth making spoken-friendly. They describe a 550 billion total parameter model with 55 billion active parameters per token. It uses a mixture of experts' hybrid Mamba attention architecture. They trained on 20 trillion text tokens, extended the context length to 1 million tokens, and claim up to about 6 times higher inference throughput than publicly available large language models in the comparison they ran. They also say accuracy stays roughly on par. The paper says it will open source base checkpoints, post-trained checkpoints, and quantized checkpoints. It also says training data and recipes are going to Hugging Face. For agents, the useful detail is how the model combines long context with active parameter efficiency and throughput in long-running tasks.
And the caveat is inside the comparison. The throughput number is on a specific setting, 8,000 input tokens and 64,000 output tokens, with their stack and precision choices. That can still be useful, especially for agents that generate long traces. Nobody should round it to 6 times faster for my app without checking hardware. The serving framework matters too, so do prompt length and output length. The key value cache footprint matters here too. Hybrid Mamba attention is partly about reducing the cost of carrying long context. An agent that keeps reading files and tool output can spend much of its time paying attention to history. Faster inference isn't cosmetic when the agent is waiting on itself for minutes.
Then, OpenSWE Traces gets very practical. The paper introduces 207,489 agentic trajectories across 9 programming languages. The data comes from 20,000 real-world pull requests through OpenHands and SWE agent harnesses. The authors say they filtered for permissive licenses, MIT, Apache, and BSD. They also describe 2 kinds of traces, explicit thinking traces from Minimax M2.5 and non-thinking traces from a Qwen 3.5 model with 122 billion parameters. The result is a training resource for autonomous software engineering models. The authors fine-tune Qwen 3 variants, including a 30 billion parameter series. For their best model, they report 61.7% on SWE Bench Verified. They report 57.1% on SWE Bench Multilingual and 36.8% on SWE Bench Pro. Those are benchmark claims, so we should not treat them as product reality, but the dataset itself is the more durable artifact.
The licensing filter is the detail I was glad to see. If you are building open coding agents, training traces are tempting and dangerous. A trace is not just the final patch. It can include commands and paths. It can include intermediate reasoning, test output, and sometimes accidental secrets if the collection process is careless. So a corpus built for a permissively licensed repositories and normalized harness output is a serious step, even if every benchmark number later gets revised. It gives smaller labs and open model teams something closer to the behavioral fuel that closed coding products already have. They get examples of agents getting lost, recovering, running tools, and deciding which edit to try next.
CoAgent is the concurrency control paper in the group, and I like it because it starts from a problem anyone who has run parallel agents can recognize. 2 agents mutate the same Git tree, Kubernetes cluster, or document. Classical transactions assume quick operations and controllable state. Agents run for minutes or hours, touch broad read sets, and act on external systems where writes may already have happened. The paper's protocol, MTPO, fixes a serialization order at launch. It lets agents write speculatively. Then it notifies affected agents when another write may invalidate their plan. The agent judges whether the conflict matters and repairs only the dependent steps. Undoable tools provide inverse operations for writes that have to be reordered. The authors report near serial correctness with a 1.4 times speedup on contended workloads, plus a bash-only experiment where a toolsmith grows a tool library online.
This is the kind of agent paper that feels close to engineering practice because it admits the ugly bit. The external world already changed. You can't always stage a Kubernetes apply in a private buffer and commit later like a database row. Sometimes the service has been touched, the file has been edited, or the cluster state has moved. The optimistic part is asking the model to judge whether a conflict invalidates its plan. That is clever, and it is also the risky assumption. The paper says notified agents misjudge relevance in only 5% of trials in their evaluation. In production, I would want replay and logs. I would also want a way to keep the human operator from trusting a confident repair that patched the wrong premise.
FragFuse is the security paper I would pair with that. It looks at agents with long-term memory and access control mechanisms. The attack fragments prohibited content across interactions, stores the pieces in memory through benign-looking carrier queries, and later retrieves and fuses them so the final query doesn't explicitly contain the prohibited content. The authors report an average bypass success rate of 86.3% and an average end-to-end harmful task success rate of 41.1% across their tested settings. Again, paper numbers need replication, but the mechanism is the lesson. Memory can become a temporal channel around access checks if the policy only inspects the current query.
That one should make product teams uncomfortable in a useful way. Memory is marketed as personalization and continuity. The user doesn't have to repeat themselves. The agent remembers preferences and past work. But if memory can carry fragments that later become a denied request, access control has to cover retrieval and stored state. It also has to cover the moment when the model fuses old material into the current answer. This is where the research cluster ties back to the product stories without forcing it. Cursor, GitHub, OpenAI, Anthropic, and the open model papers are all circling systems where agents are no longer one prompt and one answer. They have memory and tools. They have traces, cost controls, ownership incentives, and policy constraints. That is a much messier object to operate than a chatbot.
France is reportedly planning 655 million euros in AI investments through 2030, along with a Mistral-powered chatbot for state services and a move by its security service away from Palantir toward Chap's vision. TechMeme has that as the state AI procurement item today. I would keep it brief, but it belongs in the episode because it shows national AI strategy becoming vendor selection. A government can talk about sovereignty in broad terms for years. Procurement makes it concrete. It decides which chatbot handles state services. It decides which company supports security tooling, which vendors are acceptable for sensitive work, and which domestic firms get demand that helps them survive.
And it is a useful counterweight to the US-centric model access fight. In the Anthropic story, the state acts by restricting a frontier model. In the France story, the state acts by buying and replacing vendors. Both are power over AI systems, but one is a gate on access and the other is a demand signal. For builders, procurement can matter as much as benchmarks. A domestic model or services company can become more capable because the state gives it real workloads. It gets integration pain, support requirements, and a reason to harden the product. That is less glamorous than a leaderboard, but it is often how software becomes institutional.
So the route through Tuesday, June 16th, isn't one grand theory. Ownership, money, policy, and engineering facts are meeting inside the developer workflow. Reuters and TechCrunch report a $60 billion deal for the company behind Cursor. TechMeme surfaces reported OpenAI spending at $34 billion. The Anthropic access fight gets new reporting from The Verge, Axios, Indian Express, Forbes, and The Register. The archive cluster gives us open checkpoints and coding traces. It also gives us agent concurrency work and a memory attack. GitHub reportedly needs more capacity. France is turning national AI talk into vendor choices. If I were running a team that depends on these systems, I wouldn't respond by panicking or by pretending nothing changed. I would update the dependency map.
That means writing down the dependencies. Which agent features depend on which provider? Which coding tool sees which repositories? Which memory stores are trusted? Which fallback model is tested? Which price or capacity limit would force a product change? It also means asking vendors for documents you can route to security, legal, and engineering. You need data retention terms. You need model routing policies. You need reliability commitments and a process for access restrictions. The exciting part of agents is that they can do more of the work inside the system. That extra reach forces more of the system into writing. When a tool gets bought, a lab's spending becomes visible. A government can restrict a model, and a memory feature becomes an attack path. The engineering answer is to make the hidden assumptions visible before they make the decision for you.